All right, folks, so this is our 1.2 notes. We're going to be looking at classification of matter. So on your notebook or your piece of paper, you want to label it 1.2. And we've talked a lot about last week about how matter is anything that has mass and takes up space or has a volume. We learned that there are three common states of matter: solids, liquids, and gases, with the fourth being plasma, which is very common out in space, but not as common here on Earth. So all matter either is a mixture or a pure substance. Okay, so if we look at our pictures here, these blue squares, all of them are identical. That's a pure substance. These red circles, they're all identical to their neighbors. It's a pure substance. Even down here, these green circle square combinations, because this unit is the same as its neighbors, it is also a pure substance. So we call it a compound, but it's called a pure substance. Where over here, because this looks different from that, looks different from that, that makes it a mixture. So whether the neighbors all look the same or not is whether it's a mixture or a pure substance. So again, we'll talk about each of these. Okay, so a mixture is two or more pure substances that are combined together. They're attached with what's called a chemical bond. Okay, so if I look at my picture here down below, this is a pure substance because if I pick one thing, this one, every single one of these, even though they're rotated, looks exactly the same. Over here, if I pick one thing, this yellow circle, the other things don't look exactly like that yellow circle. I got blue circles too. So that makes this a mixture. Even though both have blue and yellow circles, these here, they're attached and everything looks the same. Here they're not attached and everything doesn't match. It's not all the same. So this is a mixture. Okay. Now you can separate these particles from each other and we'll talk more about that later. A pure substance, on the other hand, is something that cannot be broken down physically. You can't separate it. Instead, you have to use chemical means. You have to use a chemical reaction. Okay. And then as far as us, it also has a very specific chemical formula. So a substance like this might be NaCl, sodium chloride. That is a formula for a pure substance. This mixture doesn't really have a formula for it. Okay. So if I have a formula, it's probably a pure substance, and if I don't, it's probably a mixture. Okay. As far as mixtures go, if we can also classify them as being homogeneous, which means that it looks the same throughout, or heterogeneous, it looks different throughout. You have visible differences. Okay. So an example of a homogeneous mixture, if I were to take my water bottle here, look in the water, okay, there are dissolved salts in here, minerals, okay, because it comes from, a spring or tap water or city water, okay. It's not just water. It's not just H2O. I don't see the minerals floating around in there, though, okay. So that means that this is a homogeneous mixture. It looks the same throughout, okay. If I were to throw a spaghetti noodle in here, now I have a heterogeneous mixture because I can see the noodle. It's different from the water. Visible differences means you have a heterogeneous mixture. Okay, I'm going to have you pause the video for a second, and I want you to try to identify each of these as being homogeneous or heterogeneous. So make two columns in your notes and try to put them in there. Okay, some things that are a little difficult. Okay, if you have cement, think about looking at it really closely. Pulpy orange juice, the pulp is that kind of solid fruit material that's in there. Jar of buttons, consider that there's a jar there too. And garden salad means there's a lot of vegetables in there. So I'm going to go ahead and have you pause, put these into one column or the other, homogeneous or heterogeneous. When you're done, unpause the video and see how you did. All right, so you should have checked these already. Okay, so here's our list. Some things to be careful with. Cement has tiny little particles. There's little grains of sand. There's small rocks in there, and there's also other materials. So that's going to look different throughout. Okay. River water is going to have mud and maybe insects, other kinds of things. It looks different throughout it. Okay. Garden salad, if you can pick out the tomatoes, if you can see the croutons, then it is heterogeneous. You can see visible differences there. Mixtures we can separate out physically, so we don't use chemical reactions, we don't change what they are, and that's something we'll be looking at later as to how do we actually separate a mixture. How do I get the blue squares separated out from the red circles here, that kind of thing. Different ways that we can use to separate mixtures. You can filter it. So in chemistry, we make a lot of solid material, and we'll filter that out from a liquid. Okay, we use filter paper and a funnel, and we'll look at different setups for that as the semester goes on. Think about it with a coffee filter, if you've ever seen that. So then the water goes through the coffee grounds, and only the desirable things, the things we want to drink, the things that we like the taste of, come through on the other side. So that's a way of separating out a mixture. Okay, we can melt or freeze things. You can sort it so you can pick out the things. Okay, if they're big enough to do that with. You can use a magnet if something's made out of iron. You can centrifuge it, which means to spin it really fast so the solid gets pushed down towards the bottom. It's like what they do when they take a blood sample at the doctor's office. They centrifuge it to get the red blood cells separate from the white, from the platelets, from the liquid, the plasma on the top. You can, if you have two liquids, you can distill them. So one will boil off at a lower temperature, so it'll boil off first. That's what they do to get to make gasoline from oil. They actually boil off the chemicals that are in different things, and that's how they get kerosene, gasoline, all these different materials from natural oil. Okay. Chromatography you use to separate out solids that are dissolved in a liquid, but dissolve differently. Pure substances are either an element or a compound, so we're going to look at how we classify them. An element is the smallest building block of matter, and it's only made out of one type of material. Okay, so it's the simplest thing. And really how you can tell is based on the number of symbols. So you look at your periodic table of elements. I'll be linking one on our Canvas page that you can use. And elements are made out of atoms. So here I have copper. All the copper atoms are identical. Same thing with the aluminum. They're all identical. Okay, so that makes this an element. Every piece is the same as its neighbor. Okay. So elements, how do you know you have an element? Well, is it on the periodic table? If you can find it on the periodic table, it's an element. And also that symbol only has one capital letter. So if your formula has only one capital letter in it, then it is an element. So if we go back here, H2, there's just one capital symbol. O2, just one capital symbol. So all of these are elements because there's only one element symbol, only one capital letter in it. Okay. There's 118 elements that have been discovered so far, and we'll talk a lot more about that when we get to the periodic table. Compounds are different. They're combinations of two or more different elements. So you're going to have more than one symbol in there. You're going to have multiple different elements in there. So you'll have one capital letter, two capital letters, three capital letters, however many you need. But it's two or more capital letters to make it a compound. So O2 is not a compound. There's only one symbol, only one capital letter. That's an element. Water, H2O, two elemental symbols, two capital letters. That's going to make it a compound. Okay. The smallest part of a compound is called a molecule. We can separate pure substances only chemically, so you'd have to change it. That would be for a compound, so you can actually break compounds down into simpler things. You cannot break an element down into simpler things. So go ahead and based on these, try to see if you can identify them as being pure substances or mixtures. So water, hydrogen gas, salt, tea, and sodium. This would be a time to pause it. Is it a pure substance? Can you write a formula for it? Or is it a mixture? Can you not write a formula? Again, pause and then check in a moment. So we have our pure substance, mixture, and pure substance. Again, the only one that's going to be a mixture here is number 4. It's going to be tea. The rest of these you can write a chemical formula for. Tea is made out of a variety of things. You can't write a formula for it. Okay. Element or compound. Put a couple here on the screen. Okay, go ahead and pause the video and try to identify these. They're all pure substances. Are they elements or is it a compound? You can use the abbreviation E or C if you'd like. And here's our answers. Okay. So again, the number of symbols determines is it an element or is it a compound. One last thing, can you classify these as being homogeneous or heterogeneous mixtures? Pause it, and then go ahead and check in a second. Okay, so there's our options there. Alright, so folks, that concludes our notes for today. Make sure you fill out the Google form at this point. That's going to count as your attendance
for today.